So this is the lesson on the trigonometry or trigonometric area rule. So to find the area of a triangle using base times height divided by 2 or a half base times height, we must have the base and the perpendicular height of the triangle. But the formula A equals a half AB sine C. This formula allows the area of a triangle to be found when we know just two of the sides and an included angle. So we don't necessarily need to know the perpendicular height. So if you look at this purple triangle down here, if we knew this angle down the bottom labelled in red there, I'll go over it in black. If we know this angle C and we know the side lengths A and B, we can find the area. Whereas before we would have to know the base, so we'd have to know A, and we'd also need to know the perpendicular height. Okay, which we don't always know. So let's do two examples first. So here we have to just find the area to three significant figures, and we know that the trigonometric area rule is A equals a half AB sine C. So let's label up the triangle. If we call the angle C, that means the opposite side length is C, with A and B being the other two sides, and we can just sub in for the different values. So a half times by 6 times by 7 times by sine 60, and we get the answer to 3SF is 18.2 centimetres squared. So that's a really nice simple application. This next question is a little harder because we are asked to find the area to the nearest square centimetre, and so that immediately we should be thinking, okay, well actually immediately we should be thinking, can I do base times height divided by 2? Because that's the easiest thing to do, but we don't know the perpendicular height, so we can't do that. So we're now thinking to use our new formula, a half AB sine C. Now, I do know two of the side lengths. I know 18 and 20. But I need the angle in between those in order to use a half AB sine C. So really, I'm going to need to find the angles in the triangle. Now, specifically, I want to find this one. So we need to think about what we can do here. Now, we do know that we have the sine rule and the cosine rule that can help us to find angles in triangles. And because I've got the 60 and the 8, which are opposite each other, I'm thinking, the sine rule would be a good choice here. But the sine rule is only going to allow me to use the 20 to find angle B out here. So my first step, and I'm going to label this step 1, is I'm going to find angle B. Now I know that I want angle C, because remember, to do a half AB sine C, I need this angle here. But I'm going to have to just find what I can to start off with. So I'm going to do, I'm looking for an angle, so sine B over 20 will be equal to sine 60 over 18. Now, that means that sine B will be equal to 20 sine 60 over 18. And then to get the angle B, I need to do inverse sine. So B is equal to the inverse sine of 20 sine 60 over 18. And when you pop that in the calculator, we end up with the number 74.2, blah, blah, blah. Now I'm storing this in my calculator as A, because I don't actually really care about this angle. I'm only going to use it to find angle C. So step 2, I'm going to find C. Notice I'm numbering my steps and I'm telling the examiner what I'm doing. Okay, so now I'm finding angle C, which to use angles in a triangle is really simple. So I'm going to be taking away 70.20 dot dot dot, whatever. But really in my calculator I'm doing 180 minus 60 minus alpha A. Okay, now when we pop that in, we get 45.79, blah, 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 blah. And I'm going to store that as B, because again, this isn't my final answer. I actually want to find the area of the triangle. So now that I know this angle, I can come over here and do step 3. So step 3 is to just find the area. Now, if you want to, you can redraw the triangle at this stage with the relevant information. So we know 60 over here, and we've just found that this angle is 45.7, blah, blah, blah. And again, if I label this as angle C, and then I've got sides A and B, I've got an angle with two sides, I've got the two sides, with the angle in between. So I am going to do a half times by 18 times by 20 times by sine 45.7 dot dot dot, which in my calculator is going to be sine of b, sine alpha b. And when we pop that into the nearest square centimetre, so the nearest whole number, you should get 129 centimetres squared. So that's to the nearest centimetre squared. And there we go, that's our final answer, and I'm happy to round that. So that's the first two examples, and on the worksheet you have these three questions to complete. So hop over there and complete them, and then come back to the video for the answers. Okay, so just to quickly mark your work then, we have the answers here to 3SF for each.